video, I had seen different type of comparative exam which had come in linear algebra. Today's first goal is I will also discuss some question which had come different type of comparative exam. But today's actual goal of this lecture is companion matrix. This is special type of matrix, but this matrix is very important for any comparative exam. This is actually very special type matrix. In this matrix, always characteristic polynomial and minimal polynomial always be same. And there exist many property of companion matrix, which is very important for any comparative exam. See one question which had come GATE exam. The question is, let A be 7 cross 7 matrix such that 2a square minus a to the power 4 equal to identity, where I is the identity matrix if A has two distinct eigenvalue. Notice here the matrix indicate it has two distinct eigenvalues and each eigenvalues has geometric multiplicity 3. Okay. Then total number of non-zero entries in the Jordan canonical form of A is equal to. This type of question I had discussed in my previous video also. But at first I will highly recommend you, if you don't see my earlier video about Jordan canonical form and about the question which had come different type of comparative exam, then please see this video. Then today's video would be so easy. Here AB 7 cross 7 matrix, and here the equation is 2a square minus a to the power 4 equal to identity, and given A has two distinct eigenvalues. Okay, and each eigenvalue has geometric multiplicity 3. If we consider one eigenvalue lambda 1, then geometric multiplicity of lambda 1 is 3. Also, if we consider another eigenvalue lambda 2, then geometric multiplicity of lambda 2 also would be 3. Notice here A is 7 cross 7 matrix. Okay, but geometric multiplicity of lambda 1 is 3. Also geometric multiplicity of lambda 2 is 3. But since A is 7 cross 7 matrix, that means from this idea we can tell, since A is 7 cross 7 matrix, then either arithmetic multiplicity of lambda 1 would be 4 or arithmetic multiplicity of lambda 2 would be 4, because here given A is 7 cross 7 matrix, but metric multiplicity of lambda 1 and lambda 2 is 3. That means 3 plus 3 is 6. But given matrix is 7 cross 7 matrix. So, arithmetic multiplicity of lambda 1 must be 4 or arithmetic multiplicity of lambda 2 must be 4. Are you getting? Then Jordan canonical form would be such type. If we consider arithmetic multiplicity of lambda 1 is 4, then Jordan canonical form would be lambda 1 1 0 0 0 0 0 lambda 1 0 0 0 0 0 0, here also lambda 1 0 0 0 0 0 0 lambda 1 0 0 0 0 0 0 0 lambda 2 0 0 0 0 0 0 0 lambda 2 0. Here also 0 0 0 0 0 lambda 2. This is the Jordan canonical form of this matrix, of this equation. Are you getting? So notice here 2 block of lambda 1 and other is 1 block, and here these are 3 block. So total number of non-zero entries in the Jordan canonical form would be 8. Are you getting the meaning? Now I will see our main goal of this lecture, companion matrix. What is the idea of companion matrix? Consider Px be the polynomial given by a0 plus a1x plus a2x square plus x cube. And suppose a0, a1, a2, a3 belongs to real number, and consider alpha, beta, gamma be the root of this polynomial. Now find the polynomial whose roots be the alpha cube, beta cube, gamma cube. Notice here alpha, beta, gamma be the roots of this polynomial. This type of idea I have known about the theory of equation. But in linear algebra, alpha, beta, gamma be the root of this polynomial means obviously this is the eigenvalue of this polynomial. And since here in this polynomial highest degree is 3 and coefficient of highest degree means a3 equal to 1, that means this polynomial is monic polynomial, and companion matrix always applicable on the monic polynomial. For this polynomial I will get one matrix, and this matrix is denoted as M, and this matrix would be such type here minus a0 minus a1 minus a2, and off diagonal of this matrix is 1 1. Notice this matrix is always companion matrix who is associated by polynomial, this polynomial. Okay? Are you getting how look like this companion matrix? And notice one thing always noticeable. Here highest degree of the coefficient of highest degree always would be 1. So this polynomial always be monic polynomial, and this polynomial actually look like such type, and by this polynomial we can generate one matrix, and this matrix is called as companion matrix. And here for this matrix I will obviously by characteristic polynomial I can get 3 root alpha, beta, gamma. Here the question, find the root alpha cube, beta cube, gamma cube of this polynomial. That means in linear algebra we have to find m cube, and we all of us know the root of m cube would be alpha cube, beta cube, gamma cube. Okay? Try to oneself at first find the matrix m cube, then find the characteristic polynomial of m cube and find the root. Are you getting the idea? What is the companion matrix? How we have to find the companion matrix? Therefore, the n cross n companion matrix would be such type. Here minus a0 minus a1 minus a2 minus an minus 2, and since I have begun from a0, this is minus an minus 1, and in the diagonal is 0 0, and below the diagonal is 1 1 1. This is the nth order companion matrix whose characteristic polynomial would be x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 plus this would be continue plus a2x square plus a1x plus a0. Okay, this is the characteristic polynomial of companion matrix, and always characteristic polynomial of companion matrix and minimal polynomial of companion matrix always be the same. This is the property of companion matrix, and this property is very important property. For this matrix, always characteristic polynomial and minimal polynomial always be the same. If you give this polynomial, so obviously this polynomial generate one companion matrix, and this matrix would be such type. Here notice the polynomial. N polynomial of companion matrix would be such type. Here does not be a0, so this would be 0. a1x, that means this would be minus 1. a2x square, that means this would be minus 2. Here also 0, 0, 1, 0. Here also 1, 0. This is the companion matrix which is generated by this polynomial. Are you getting? Oh well. Only A transpose also would be companion matrix. Notice the form of A transpose. Getting the form? That means if in the question has given this form, this is obviously be companion matrix. Also, if has given this form, then this is also be companion matrix, because this is nothing but this is only transpose of this matrix. Okay? Oh well. Now I will see one example of companion matrix which had come in comparative exam. Consider this matrix, and what is the Jordan canonical form of A? We all of us know Jordan canonical form is such type. For this, consider this is A0, this is A1, this is A2, and this is A3. Therefore, the characteristic polynomial would be from this matrix x to the power 4. Here A3 is 0, A2 is 5, minus 5x square, A1 is 0, minus 4. This is the characteristic polynomial of this matrix. Okay? Or root of this polynomial would be x to the power 4 minus 4 plus 1 x square plus 4. This is equal to x to the power 4 minus 4x square minus x square plus 4. That means just common x square here, then this would be x square minus 4 minus 1 x square minus 4, then this would be x square minus 4 times x square minus 1. Okay? Therefore, root of the characteristic polynomial is 2 minus 2, 1 minus 1. Okay? Therefore, all eigenvalue here testing, therefore Jordan canonical form would be this example. Here all eigenvalue be testing. So there exists only one block for each eigenvalue. Are you getting? Are you getting why the companion matrix is very important? Since you know the companion matrix, so you can easily find the characteristic polynomial by the rules of the characteristic polynomial of companion matrix. Okay? I will see one question of companion matrix which had come CSIR Net 2000 December question. The question is, consider n be odd order which is greater than equal to 7, and consider A equal to Aij be n cross n matrix with the condition Ai, I plus 1 equal to 1 for all I equal to 1 to up to n minus 1, and a n comma 1 equal to 1, and consider aij equal to 0 for other pairs ij. Then we can conclude as option 1 a has 1 eigenvalue, option 2 a has minus 1 as an eigenvalue, option 3 a has at least 1 eigenvalue with multiplicity greater than equal to 2, option 4 a has no real eigenvalue. This is also example of companion matrix, because we all of us know a I equal to diagonal of the matrix, and a I comma I plus 1, obviously this means super diagonal of the matrix, and here given a n comma 1 equal to 1, where obviously n be the 7, denote the 7, that means a7 1 equal to obviously 1. That means since here given a I comma I plus 1 equal to 1, that means super diagonal of the matrix would be 1. So the form of the matrix would be such type, means a7 1 equal to 1, therefore here also would be 1. This is the notation of the matrix. Are you getting? Actually this is the transpose of companion matrix, where obviously a0 would be minus 1, a1 would be 0, a2 would be 0, a3 would be 0, a4 also would be 0, a4 0, a5 0, and a6 0. Noticed? And odd super diagonal here since 1. Since here a1, a2, a3, a4, a5, a6 all are 0. So the characteristic polynomial of this companion matrix would be x to the power 7 minus 1. And this is also minimal polynomial of this matrix if you consider this matrix as A. Then from this characteristic polynomial, since x to the power 7 equal to 1, which is equal to e to the power 2 pi ni, therefore obviously x equal to e to the power 2 pi ni over 7, where n run from 0 to 6. That means that imply the root is such type x equal to 1, 2 pi I over 7, 4 pi I over 7. This would be continue. So obviously by this idea here only 1 is a real eigenvalue. Therefore in option 1 has indicate A has 1 as an eigenvalue. This is right option. A has minus 1 as an eigenvalue. This is wrong option. Option 3 indicate A has at least 1 eigenvalue with multiplicity greater than equal to 2. This is also wrong option, because here all eigenvalue with multiplicity 1. A has no real eigenvalue. This is also wrong option here, because only 1 eigenvalue, which is 1. Are you getting the option? Well, this question is very easy type question, and this is easy because you have studied what is the companion matrix. By companion matrix, we can easily find the characteristic polynomial of and eigenvalue of this matrix. Otherwise this would be very difficult. Okay? Are you getting? So my all viewers have understood why companion matrix is very important for any competitive exam. Today I will stop here, and in my next video I will discuss idempotent operator. But at first I will highly recommend you please see today's video with pay attention, because companion matrix is also very important for any competitive exam. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.